Okay, this is hopefully going to be a short video to go through the manual for using the CPLD, otherwise known as the Gatekeeper board. This board is something I made to be used in a digital electronics class that's uh, it's more modern. There's a lot of digital classes that are still using the 7400 series chips, and it's legitimate. There's obviously some values to it, but I think since the technologies comes from the 70s and 80s. However, it is still foundational to using all digital systems. You still need to understand the basics of Boolean algebra, the various gates, shift registers, flip-flops, multiplexers. All of that still comes into play, even in the most complicated systems, even within using structural and behavioral language in Verilog, which maybe we'll get to at a later point. But so I'm making this video to kind of go through the manual, walk you through it. This isn't really meant to be exhaustive. You should still read the manual. You want to read it by step. One of the things that's really kind of come up in this process of writing this manual and having students review it and then actually use it in class or just in a private setting, that the phrase, or the acronym rather, RTFM, is something that I think every engineer needs to learn. So RTFM is a shorthand way of saying read the effing manual. So a lot of times people will have problems with something, or they can't get something to work, or it's not working properly because guess what? They're not reading the manual, or they're not reading it thoroughly. They're just looking at the pictures and clicking, and then nothing happens. But so this is ultimately geared towards kind of helping the process and simplifying it. And it's also, I think, helpful to see somebody actually use the software. You can read a manual and read a description, but actually watching somebody, I think, is much more helpful. So we're just going to kind of go through, start off on page 1 of the manual. We're downloading software. So here you can obviously see I've already downloaded it, so I'm not going to go through that process, and it really makes for a boring video. But this is the website is listed in the manual. You can obviously see it up here. You want to make sure that you do not download version you don't want to select release 20.1. I think you could use 19.1. I have not used that. It will probably work, but there is a known problem in 20.1. I forget exactly what it is. I think it has something to do with the simulation not working, or some weird setting that causes it to not work. But either way, so you want to select the Lite edition because it's free. If you want to pay for it, go right for it, but you're not going to get anything worthwhile out of it at this level. So you want 18.1. Then here we selected individual files. So you can select combined files, which will just download like everything. It's like 6 gigabytes. So it might take a little while to download, but you can, so you can actually select the specific devices. So all that information, all that data you don't necessarily need are in the devices. So what you want to do is you want to make sure you select this one. You want to select the Quartus Prime, otherwise it won't work. There's no software. But you also want to make sure you add the model sim, because we actually want to do simulations. And so for the CPLD, the Gatekeeper, you want to make sure you also select this Max 2, where actually it's a Max 5 device. So this has all the data that'll be necessary. So you click those, download it. I think, you probably have to set up an account maybe, but that's kind of standard stuff. So you download that, install it, that's all automatic. And so it should open up. The first time it'll look something like this. Yours might actually look a little different at the top. I've gone through one of the fixes that's a little bit later in the manual. Okay, so that's pretty much what page 1 and 2. So you can actually read through the overview of the hardware itself. I think that's kind of self-explanatory. I just want to really focus on actually using. One of the things I do want to iterate is that you want to make sure that you want to use 3.3 volts only. It does have a 5 volt to 3.3 volt regulator on there, but I might change that for later editions because I think it might cause more problems than anything else. There's really no point. It's not 5 volt tolerant inputs, so there's really no reason to have 5 volts into it. The only reason I put it on there is I thought, the people might be used to 5 volts and they would step it down, but it's just more potential to cause problems. So the next bunch of pages kind of goes over the hardware. So you'll want to flip through, and it'll actually explain, if it doesn't make sense right now, that when you actually go to making our first project, it will make a little bit more sense. But these pages, but I guess that starts on page 6, goes through, flipping through here. Yeah, it goes through page 10. It'll actually tell you what pin in the software refers to what device on the hardware. So we're also using the interface board. I might rename that to be the keymaster. So we'll have the gatekeeper and keymaster, just for fun Ghostbusters reference. But this is, so we'll see later in a little bit of how, like for example, I'm looking at page 8, we've got PB0 as the push button. That's actually what's written on the board itself. If you actually look on the circuit board, you can see PB0, PB1, et cetera, et cetera. So when you want to use that physical switch that's labeled PB0 in the software, you'll reference pin _ 52. But that's kind of fairly obvious, but I think that should make sense. So this is when we first open up the software, this is roughly what it will look like. And to start a new project, we click, guess what? New project. New project wizard. So you can use the default file to save this. I actually prefer to use my own. So I just do, I keep it in here, and let's make a new folder, and we'll just call this lab 0.0, and oops, select, and so we want to call it a name, so we'll just call this lab 0.0. Oops. Oh, I guess it won't let me use the decimal. All right, lab 00 then. Then we want to click next. So you want to do it like something a little descriptive, like I don't know, maybe lab 1, lab 2, or something that makes sense. You know, if you just call it like Bob, that doesn't really when you look at the list of files later, you don't know what Bob was. So we'll click next. We don't have any project templates, and we don't have any extra files to add, so we'll click next. Now this is the important part. If you mess this up, you can actually go back and change it. But you obviously, if you do things right the first time, everything works out a whole lot better. So we want to collect the family of devices. We have the Max 5, and our device is going to be more towards the top of the list. So you can actually see here the different model numbers. And ours it's actually listed in the manual. Ours is going to be the M580ZE64C5. I'm pretty sure. Yep, that's it. And with that selected, we'll click next. And we don't need anything there. Click next and finish. All right. So that brings us to page 15 of the lab. And this is one of these if you go through the process a couple of times, it makes a whole lot more sense and it gets a lot easier. I know the manual has like what? It's like 20 or 30 pages. But it takes you through the entire process of installing the software, setting it all up, making sure all the drivers are installed, and all that fun stuff. But once you get it, it'll go a whole lot faster. So it doesn't come up anything because we need to select a file. So we're going to go up here, and so we're starting on page 15 of the manual, and click New. And so we're going to start with a block diagram schematic file. One of the things that's nice about the Quartus Prime Lite, well, Quartus Prime in general, is that you can actually do something as schematic. So if you know what an AND gate looks like, if you've already had a class that actually shows you how to actually draw the schematic diagrams, this is really easy because then you can actually just basically reproduce it in software, and then obviously you have to tell the software what your hardware inputs and outputs are, but it's really easy to use, really low learning curve. So now it comes up, this is just our blank canvas. So we're going to just add a couple of gates. So now we're on page 16 of the manual. So just a quick tour. This is mostly what we're going to use. You might actually have it all on like small ribbon or a long ribbon, which much smaller fonts. But again, there's a fix for this. I forget what page that's on. It's probably towards the end of, yeah, so this looks like it's on page yeah, 32 and page 33 of the manual. If you want, you can jump ahead and kind of fix that. It's just a little quick setting, but when I get to it, I'll show you the steps. So we're gonna actually look in. So this is just a bunch of our stuff. These are all the different kinds of wires, different kinds of connections. But for now, we're gonna keep it pretty simple. We're gonna use this. It comes up. This is our symbol tool. This is our pin tool, and we don't actually need this. It'll pop up automatically, as you'll see. So we're gonna start by clicking that, and it comes up. So this is just the library that has all the various functions. And you can click in, so we can look at primitives, we can look at logic. So this will actually go through and show you all the these are the basic gates. So your and, your or, your nots, and stuff like that. So it just kind of shows you how to type them in. So if, let's say, so you can actually have an and gate that has 12 inputs. So this is one of the real advantages of using programmable hardware. Well, there are many, but this is just one. So in hardware, in the 7400 series chips, I forget what the chip number is, but the largest single gate you can have on a chip, on a single 7400 series chip, is an 8-input chip. I don't think they come up any larger. I could be wrong. It happens. But so we can actually change this on so we can actually make 12. And in Verilog, you can make it's very unlimited. Like obviously you get to a certain point, it's just kind of gets a little ridiculous. The odds of you using a 12 input AND gate are relatively low, but it's nice to know that you can. So, but in this case, we want to, so we're actually going to just go down here and pretend we didn't do anything, didn't go through that list. We can actually just type AND. So it's the type of gate and how many inputs. So we have an AND gate with 2 inputs, and it comes up. And so here, I haven't pressed any of the mouse buttons, and I can just put it anywhere. I think in this case, we're just going to, let's see. All right, so this circuit looks like it goes off to that side. So I can keep clicking, and I can add a whole bunch of AND gates. If I want to get out of that, I think it's just escape. Yep. And so here, I only need 1. So I'm just going to go ahead and delete those. Now I want to go back and add, looks like I'm adding 2 OR gates. So I'm going to go back here. And I'm not going to bother searching through it. You can just type in what the type of gate it is. It's an OR gate with 2 inputs. Now, if you wanted a 3 input, you just put 3. If you wanted 4, 5, yeah, you get the idea. After a certain point, I think it looks like they just use oh, interesting. Anyway, you get the idea. We just want the standard traditional 2-input OR gate. So this is one of the primitives. One of the basics. And it looks like we want 2. We're going to put 1 here, and let's just put 1 there. Hitting escape, and I'm right-clicking to drop them in. All right, so we obviously need inputs and outputs because the circuit's useless without that. So you can click up here, inputs and outputs. That's kind of, I don't know, makes more sense to me. So you can just click input. You put we'll put A there, put B there, and we'll just put C there. I always like to line things up as best I can. Sometimes the software just works against you. One of the things you want to avoid, this is one of the mistakes I've seen students do, that they put these really close together. Now the only points that it's going to connect are either at the wire, at the gate there, or at the input right there. So like if in this circuit we actually want to run a wire from here down to here, we stand a better chance of accidentally making connections we don't want. So I always like to have a little bit of space here. I'm exaggerating a little bit. So otherwise we'll have things connect. I had a student just a couple of days ago going through this, and she was actually, she put things really close and was accidentally making connections wrong. And then it just causes problems. The software yells at you, but it doesn't tell you a super descriptive error. Then you have to copy that, and then you paste it into Google, and you think, what is this error? Then after about 20 minutes of searching, somebody finally says something useful and says, hey, you have the wrong connection. But anyway, all right, so then we also need an output, and we're going to toss that over here. So this, we're obviously, well, in this case, we're not going to have anything. So we can actually just line it up, and it will connect. So if I pull it out, the wire should stay connected. If I jiggle it around, you can see it's still connected. So that's a nice way to actually show. So we've got the basic elements of our circuit. And in order to connect things, we don't have to, you can select this wire orthogonal node tool, which really, tells you a whole lot. Thank you, Intel, for making a good description. but we can actually just bring over the connection, and I'm just going to left click once. Actually, no, I'm going to left click and hold it down, and then I'm going to bring it over. So you can actually see the box, the little connection changes to a box. Now we've got a nice connection. So I'm going to connect that. That one goes over to this input. So I can also let go, and then the wire stops. So I don't. So if I want to make a nice connection like that, then down here, this one goes right into this OR gate. So now we want to connect this up. So I think it works best if you actually just. So if I went like this, it's going to connect to these wires just because. And so I'm just going to go ahead and click delete. See, now it actually disconnected these wires. So an X tells you that there should be something connected, but it's not. So we'll just reconnect those wires. I'll go from here and go over here. So if I let go, it would connect to this where that square is. Now that it recognizes that this is not a connection, this is not a connection, but this is a connection. So it's a nice real visual way of saying, oh, it's actually connected here, not connected here, not connected there. So, and we're gonna left click and hold. So I want to, I think if I bring it over there like that, it doesn't look as neat. It doesn't look like it's kind of going in. So I like to just kind of bring the wire out to about here, line it up nicely with these little indices, and then draw it in. So you can actually start from the other side. You can go in like that, and you can even pop up like that. So it'll make one 90-degree turn for you. But after that, you kind of have to let go and just kind of keep making it. All right, so we've got the majority of our circuit built. Let's see, where am I on the manual? Have I skipped ahead? No, okay. All right, well, I think, all right, so we want to label our inputs and our outputs, and you can do it based off of, let's say we're building this off of a Boolean expression. I think that's listed on page 17. You can actually double click this and we'll just type in A, and I think you can hit tab. Nope, I lied. And you just type A, just kidding. A, yeah, we don't want A, we want B. There we go. A, B, and then this one is going to be, come on. That one's going to be C. And we also want to label our output. What did I label that? X, probably something really creative. All right, so this is the majority of our circuit. Now, the software doesn't know anything. We don't have any check marks over in the task menu. So we want to, so for all it knows that we're just still drawing around. So one of the things we want to do is that we want to compile it. So we'll just, and we'll do this at various steps. So we'll just compile that. Yep, it's been modified. You want to save changes? Of course. And we'll just keep the same lab 0. So it's still in our same folder. All the files will be contained within the same folder. And I'll click save. Now it's going to do all its fun processing and analysis stuff. It's just assembled. So this is basically the machine does a lot of the work for you. It's going to go through and optimize your circuit. Maybe, like obviously our circuit's pretty simple that, it's not really going to need to optimize it. So depending on the complexity of the device, this might take a while. You can actually use some FPGAs that are very complicated, whereas you compile it, then you go, I don't know, run some errands, go home, take a nap, that kind of thing. No, that's not that long. All right, so now we have our circuit built and compiled. We actually want to, we always want to first simulate it. So first we need to actually go through and set up, make sure that our software and all that stuff is set up to actually do the simulation. So we're going to go up to, see, I'm on page 18 of the manual now, and we want to go to, see if I can actually RTFM. So we're going to go to tools, then we'll go down to options, and we'll click that. And we want EDA tools. So that is right there. So here I have the, so this is just navigating. It's telling the software where the simulation software is. So why it doesn't know that automatically has more to do with that you can have different simulation softwares. We're just going to use the default one that's included. we're not going to do anything fancy at this point. So it might, so it's probably going to be some kind of file path like that's listed. But what's best is actually to, if you type this in exactly into your window and it doesn't work, you'll actually want to navigate. So let's actually go to, let's see, this PC. I'm gonna go to C. Let's see if I can actually find it. I think Intel FPGA Lite, is that where I have it? Yeah, 18.1. Yeah, then we would click here. And then, yep, that should be, yeah, that's the same file path. Intel FPGA 18.1, oh, jerk. 18.1, model sim, and then, yep, and then we actually want to go down and then click Win32. So your file path might be a little different, but it might not. But if it doesn't pop up automatically, you can either type it in. If that doesn't work, then you can actually go through and find it. It should be some kind of similar file path, but we have already selected that. So you would click select folder. You would highlight that, then select folder. But I already have that, so I'm just going to hit cancel. And then we'll click OK on that. And we also want to, let's see, still on page 18. I'm going to go up to assignments, settings, and where am I going? EDA tool. Am I already on it? Yeah. EDA tool, simulation, and yeah. So so right here I don't have the actual model simulation tool selected. So I'm going to do model sim Altera. And timescale, we don't need to worry about that. We're doing Verilog. Well, it's going to do Verilog. We're going to do the block diagram for now. And then you can click apply. Okay. And that should, yep. So we got so we have our simulation software set up. Now we want to actually run the simulation. Yeah, well, sorry. So I'm on page 19 of the manual. We've already actually compiled it. Let's see. So now we want to go up to new. We want to, let's see, it's down here, university program. And we'll click OK. That should bring up the nice simulation. So this is basically, it's going to be our waveform table. So you can see there's a whole bunch of things that we will be able to select. All of our waveforms, our inputs and outputs will be here and there. But like everything else, we want to first set this up. So we're going to go to, let's see if I can RTFM properly. Yeah, simulation view, edit. Yeah, right. Excuse me. So we go to, let's see, set end time. Yep, that's it. So the end time, this is basically how long of a simulation do you want to run? Like what's the entire time? If you want to run through all the possible, like, you want to exhaustively run through all the possible inputs and get all the possible outputs, how long does that need to be? So in our circuit, we only have we have three inputs. So that means there's 8 possible 8 total possible inputs that can be put in. That was redundant. And so we want, so let's just say one clock pulse or one high, one low was 1 microsecond. We'll just keep it microsecond. The time scale doesn't really matter for what we're doing. So we want 1 microsecond, so 8 possibilities. So let's just do 16 microseconds for our entire time. So we'll click OK. And we want to flip over to page 21. Now we actually want to set up our actual individual time. So right now it doesn't have any specific like how long we want a single clock pulse to be. Actually, we're setting it up for half clock pulse. So we'll go back up to where it says edit and go back to grid size. So we were at microseconds, so we still want to be at microseconds. So we want to change this down to 1 and we'll click OK. So now it breaks it up into individual 1 microsecond segments. And sorry, so we now have our time set up. Now we want to go through and actually select our inputs. So we want to go to select, insert node or bus. Now we want to go, we don't have to worry about all this stuff. We want to just go to node finder. And we want to go to list. And then we want to, you can actually select them in order, like, you know, let's say hypothetically speaking, your output was up here, but you want so we're going to order how the waveforms appear. I always like to have the inputs on the top and then the output on the bottom. I like to have things grouped. Otherwise, if you have A up here and B up there and C here and X somewhere in the middle, it doesn't make any sense. So if you actually want to go through, let's just say, you know, we've determined just arbitrarily that C is our least significant bit. We can put that on the bottom. So whenever we go through and make up our table of values, then it just makes more sense. So we'll just import them all. And so we want to select them. So this is where you could actually, let's actually go back. Let's just say I wanted this on the top, and then C is my, let's just say I want to go from my most significant on the bit on the top and then on the bottom, and C on the bottom. Then I can do that. So my output's going to be on the top, but so you can actually change that and be like, you know what, I'm indecisive. I'm actually going to go back and say, you know, I want that on the bottom. So it all has to do with ordering it so it makes sense, so it makes it easier to read. So click OK. And I think we click OK again. So here we have, we don't actually have actually any information. It just says, hey, these are my inputs and my outputs. So this actually means it's like high impedance. It means it's not actually there electrically. So we want to actually go through and change that. So we want to go through and we're going to select, let's see, what do I have in the instructions? Let me see if I can follow this actually. All right, so we're going to do C first. So we want to make sure we select that. So if I don't have it selected, then none of these actual buttons are clickable. So if, once I click C, then that means these are selectable. So we want to go up to a count value. So all we're going to do in order to get these to generate all the possible outputs, it's a simple way. So if you're actually drawing a table, you can actually draw C as like, you know, 0, 1, 0, 1, 0, 1, 0, 1. And then B is going to be like 0, 0, 1, 1, 0, 0, 1, 1. Then A is going to be 0, 0, 0, 0. And then 4 more ones or 4 ones. So we're going to do the same thing graphically. We're going to go 0, 1, 0, 1, 0, 1, etc. But this is just being graphical. Graphical? All right, so we click that, and we're going to go up to this. And then it's basically asking to alternate it. And so we want to make sure we're on the microsecond scale. Then I'm going to change that to be every 1 microsecond. So click OK. So it's low for 1 second or 1 microsecond, high for 1 microsecond, etc. So now we don't want it to repeat every half. Well, we don't want it to repeat every or to alternate every microsecond. We want it to alternate every 2 microseconds. So we'll go up to, we've got B selected. We'll change 1 to 2. Click OK. Now it's low for 2, high for 2, low for 2, high for 2. Now A, we want it to be low for 4, high for 4. So we're going to go through the same process. We've got A. So A is just, in this case, it's arbitrarily our most significant bit. So we're going to go back up to count value. We're going to change this to 4 microseconds. Click OK. All right. So now we've got, so on page 24, you can actually see the table that I'm kind of referring to, where it has C is our least significant bit, and it changes as you go down the table, 0, 1, 0, 1, etc. And okay. So now we want to go up and click File, Save, and I'll just keep a waveform. And that's saved. And once we saved, now all we need to do is run it. So we can actually go up to simulation, run functional simulation, click OK, and fingers crossed. Hey, there's our output. So this actually shows you in waveform it shows you graphically how the function of this circuit. So here this is time 0, and this is time 16 microseconds. So here we actually go through the entire cycle twice, or just about twice. Maybe I should have had 17 so we can actually see a drop off. But here we have you can actually go through at each of these points. So our inputs are 0, 0, 0, which is the top of our table. Our output is 0, and then our inputs are 0, 0, 1, which is the second possibility, and our output is 0. And then we have 0, 1, 0, and then our output is still 0. Now, according to the table, all of the rest of the functions, all the rest of the outputs, all the rest of the inputs should generate a high output. So we actually keep going through the table. We've got 0, 1, 1, and that gives an output of 1, and etc. So we do a simulation to actually go through and confirm that our design works. It gives the outputs that is expected. And now we can go confidently that our circuit should actually work on the hardware. So this is all the reason. So if you actually had, for example, if you had some errors in here, you would want to go back and see if you've got a wire hooked up improperly, or it's maybe it wasn't making a connection, or you actually have a wrong design. So now we want to go through, now I'm on page 25 of the manual, we want to go through implementing the circuit on hardware. And so I'm just going to minimize this. This is something that you would want to include in a lab report or any kind of design. All right, so let's go back to the software. All right, so this is always the fun part. Now we want to implement it on hardware. Let's see. Yeah, I'm on page 25. Okay, so we have this all compiled. The software knows how this is supposed to function. Now it needs to know how. Now it needs to actually build it. So when we want to go up to here, our pin planner. So this is actually going to show us a picture. Let me make that a little bit larger. So this is the physical layout of the actual chip itself. This isn't the actual board. This is the actual chip. So if you actually look on the Gatekeeper itself, that I don't know if I call that large, but the black square chip that has pins on all 4 sides, that's the actual CPLD itself. The rest of it is just support electronics and clock oscillator, voltage regulation, and some capacitors. So now we want to tell the software, we want to say in software what pins I want to go which places. So this is the part where you would go back to, what page is that, like 6, 7, and 8 or something like that? Yeah, starting at page 6, 7, 8, and I guess it goes till page 10. Yeah, so this is where we would decide where we want things to go. There's 10 slide switches and 4 push buttons. So the push buttons are going to be more for like a momentary. So you wouldn't want to use them to kind of go through all 8 inputs of the truth table, or all possible inputs in the truth table. You'd want to use the slide switches. So the slide switches are on page 7, and we're actually going to go. So usually the least significant bit is going to be on the furthest right, and the most significant bit is going to be on the left. So I think we said that our C input was the least significant bit, and so we want to have that be pin 32. Is that right? Let me just double check that. That actually might be a mistake. Yeah, all right. So the image in figure 56 looks like there's that's an error. And so that's actually, yeah. So this is a lab I wrote when I was using just the CPLD on a breadboard, and I just chose those inputs. So we actually want to, stop it. So we actually want to go back and change what's actually listed in page 56 and I'll make the changes in the manual later so other people don't get confused. So we actually want pin 8, we want C to be pin 18. I'm actually glad I went through this. So let me just type in all caps pin underscore 18, and you can hit enter. So we want B to be slide switch 1. So that's pin 13, pin underscore 13, hit enter. And then A, which is our most significant bit, that should be slide switch 2. That should be pin underscore 12. Pin underscore 12. Then our output is going to be, I wanted to use one of the LEDs. I want to use D0. You don't have to use any particular LED, but that is pin 31. That's on page 8 of the manual. So pin underscore, what did I say? Pin 31. Did I say page 8? I'm confusing myself. Pin 31. There we go. Okay. So now you can actually see as I typed it that it actually had the highlighted which physical pins on the device that we're using. But since it's actually on the CPLD and it's all wired for you, that you don't actually have to worry about connecting that specific pin. You just have to make sure that you're actually connecting to the correct pins. All right. Now I got that sorted out. All right. So now we don't, would be nice if there's like a button you clicked that said, hey, accept that, but the software just keeps track of it. So I'm just going to minimize it. You can close it. It won't matter, but I like to minimize it just in case I want to make changes. So you can see it recognized that we've made changes. So now we want to go back and recompile. So every time we make changes in the software, the software itself needs to actually set those changes. So we click that, and then we get to go through the waiting game. This is where we cross our fingers, but we shouldn't have any problems. Obviously, the only thing we've done is change the pins input and output. Yeah. So the next step that I'm going to do is, I wouldn't say a problem, but it's, so I'm kind of jumping ahead onto page, well, not really page, I'm on page 27. All right, so next thing we want to do, so that all checks out. Everything's good. Now we're good to go and actually load the programmer. But we want to make sure that we have all our hardware. So obviously I already have it all set up. I have it up here at USB Blaster. But there's a good chance you're not going to have anything, especially if you've this is your first time using it. So what comes with the kit is a not a genuine Altera branded, but it works, and I've used these a bunch of times and have not had any problems with the hardware. But you need to actually install the driver for it. So here I've done that. I'll take you through the process. The instructions are on page 28. They're in Intel. One of the things that came up just a couple of days ago was that in, let's see, on step 1, it says the instructions from Intel say plug the USB Blaster download cable into your PCB. The found new hardware box dialog appears. And what happened yesterday was that that dialog box did not appear. So this is about, so if it does appear, then you can just follow the instructions. But if it doesn't appear, we'll actually have to do it manually, which they kind of show you how to do that in figure on page 28, but it might not work terribly well. So let's say hypothetically this is all blank, nothing's here, nothing's actually selected or anything like that. So what we'll do to install the drivers, you want to go down to your menu here, type in device manager, enter. And what will appear somewhere around here, it'll be like USB, like not down here, but somewhere you'll see like a little triangle with a yellow triangle with an exclamation mark. You'll want to click on that. Let's see. Can I actually find where it is? Here's system devices. Anyway, so it'll be somewhere on here. Well, it should say. Anyway, is it not appearing? I'm probably just missing, going right past it. Here we go. So this wouldn't actually, so if it has an asterisk, so it has a yellow triangle with an exclamation point, it means you don't have to use the correct drivers. So what you do is you can right click on this and let's see, what does it actually say? Don't search online, blah, blah, blah. Yeah, so you do, let's just go ahead and click update driver. So what you would do, you would click browse my computer driver software. So I'm going to go ahead and do this, but I'm not actually going to click OK. So you want to click browse. And I think I'm looking at instruction number 0.6. So we'll go to, basically want to navigate towards the Quartus. So that would be this, Intel 18.1. Let's see. Prime installation should be somewhere where it says drivers. Quartus. Yeah, drivers, and then USB blaster. So you don't want to select one of these two, like it says in a small note underneath 6. You actually just want to click that, and then you'll click OK. I'm not going to do that because I've already done that. And then it should install the drivers, and then and that should work. I've had a number of students go through this process. Nobody's had any problems. So you would click OK. I'm going to click cancel. I'm going to click cancel, and I'm going to make you go away, and I'll close that. So what will happen is that it might still come up nothing. Then you'll just click set up hardware. Then you should see it down there, and then so you might come up like that. So yours, it'll come up as hardware available, but it says no hardware. So you just come up here and click USB blaster, and then you click close, and then it should appear up here. All right. Now the next step, and this is one of those things like, this is turning out to be a lot longer of a video than I thought it would, but once you go through it a couple of times, this takes you like maybe a minute or two to go through it. All right, so yeah, so let's just pretend, yeah, so anyway, so we can go through, follow the manual, follow the instructions onto through page 29, and now I'm on page 30. That will actually go through and bring up these files. Let's see, what am I doing? Auto detect. Oh no, wait, silly me. Excuse me. You actually want to click the files that you want to upload, and then go through instructions on page 30 on how to do that. And once everything's done, make sure that everything's connected. The USB blaster. If it wasn't connected and you're trying to connect to it, it wouldn't show up in your USB. So it should be connected. That's connected to the CPLD board. The CPLD board is on the interface board. The interface board is connected to power, turned on, and you should have 2 lights on. So everything is good. We should click start. So another cross your fingers. And we're successful. Now, if I had an extra camera, you could actually see this. So you can actually go through all of using the switch 0, 1, and 2, and looking at D0, you can actually go through the basically the whatchamacallit, truth table on page, let's see, what page was that? So many pages ago. Yeah, that's on page 24. And you can go through all the possibilities and verify the truth table. And that should be it. Oh, also, there's on page 32, you can actually go through, there's just 2 pages on changing the format, because I know a lot of times the schematic just comes up kind of funky. After that, so you should be able to follow these instructions, this part of the manual, to do any of the labs in the manual or any of the labs on your own. If you have any problems, feel free to reach out. All right.